Hi guys, welcome back. Take a little break here before we get started, and I got myself some delicious coffee. Can you see that? That's great. That's a little crema. You see, that's espresso. Hey, so now after we just ran that code, right? I'd like to show you how to load it and plot it, and then I'll show you a script file that I wrote for it. So let's get started here. So the objectives are to go over the irrotational numeric solution for flow over a forward-facing step. We had already run the code, so now I'm going to show you how to load the DAT file and then how to contour plot, which I've already talked about in a previous computer lab module. And then I'm going to show you a little bit of plotting, a little bit of features within Octave, and then introduce you to a script file that does plotting for me. And within that script file, there's a method to make plots to generate files, plot files, so that you could put it in a document or whatnot. And then I'll show you this flip LR at the very end, just because it's kind of convenient. All right, so let's get to it. This is where we were last time, and I had just run this. I just edited the M file, and we had run it. And when we ran it, it scrolled up these files here, all these DAT files. And so if you look at the code, it's a little bit confusing because within the for loop, right, it's supposed to be printing out the file name here. And the reason it printed it was because there is no semicolon at the end of this line. Anytime you put a semicolon on the line on the end, it suppresses output. So to put the semicolon there means it echoed that to screen. So you can see here that it echoed the first one, which was actually done up here, and then it echoed each sequential one, and all the way down to I step of 40. And so that came from this line right here. And all this other stuff was all suppressed out by the semicolon. If you don't put the semicolons in there, it just scrolls and it just writes and writes. And the slowest thing a computer does is write to screen and write to the disk. So we want to suppress the output as much as possible to make the code fast. Okay, so I would like to look at the S file. This is the solution. When I put it up here, it doesn't look it doesn't line up. Like here's the step. It's in the left-hand corner. It should be in the right-hand corner. So I can use this if I transpose the vector by this half quote here, it's still not right because it puts the step over here. I want the step to kind of line up with this picture here where it's in the lower right-hand corner. So I think this will do it. Flip LRS. Yeah. So this flip command, you can see here it's actually putting out, this is our psi, this is the converged psi, right? So here's the interior of the step. Here's the -1s that we didn't march in time, right? So they stayed -1, which was the initial condition. Here is the inlet here, and that's 0, 1, 2, 3, 4, 5. Here's the flow across the top, all the 5s, and then here is the exit. What will happen if I flip this within the flip? You can see it put the -1s on the upper right-hand corner. And there's the streamline along the top. They're all 5. Here's the exit. Here's the entrance. All right, well, enough of that. Let's contour plot this. So if I type contour and I put in psi. Did I load this yet? No. First I have to load the file. Let's see what we got in there. See, I don't have anything, but all I've got is the last psi. So let me load the first one. Load PSI, with 6 zeros. 1, 2, 3, 4, 5, 6, dot, dat. Okay, and now, there it is there. 10 by 6, that looks right. So then I can contour plot this. PSI 2, 3, 4, 5, 6. Notice it opened up this AquaTerm. AquaTerm is the Mac version of Xterm, kind of, Java. When you run Octave, you can pick what your graphic window will be. I like AquaTerm just the way it looks. So in addition, I loaded AquaTerm and then did a set terminal for Octave to display to AquaTerm. This is not right, or let me just flip it like this. That looks a little better. So this and this is this solution that I showed you here, right, or thereabouts. I think there's a little difference here, but essentially what you see is that in this region is where everything was -1. Oh, I think this was the first time step. This is the 0th time step. Everything is -1 here. And then Octave is doing its best to write contour plots. Well, if these are all the boundary conditions and the interior is all set to -1, and then there's a step at 0, it says, oh, well, if this is -1, if this is the -1 line, then this has to be the gradient, right? So it's forcing all of the 1s, 2, 3, 4, 5 value of the streamlines into this narrow band and then back out where it kind of matches back up with the output conditions. So that's the way it looks. That's why it looks the way it does right there. We should be able to, if I do one of these guys, if I set the handle, let's see if I can recall what this is. Oh, I misspelled it. See, I set the handle here like I showed you before, I think, for the contour plot output, and then I did a C label, which is the contour label. Now you can see all the contour lines, and it just picks whatever lines it wants to, right? We can set the contour lines, or we can increase the number of contours. I guess it didn't like that. I gotta look that command up. All right, so instead of me guessing, why don't we do this? Let me show you what this VI plot psi is. This is a script file that I wrote, and what it'll do is it'll automatically come in and it'll read in every one of our time dumps, and it'll throw up a plot of it onto the screen, and then it's going to write it to file. Let me show you how it works. So it's going to march through from 0 to 40. So this is the logical loop that it gets all 40 files. And then again, it builds its file name. So it knows that the file name is psi plus this 6-digit integer, and it converts it from number to string, .dat. And then that's all within this bigger command that says load. And so that's a string. And then in order to actually get Octave to evaluate that string, you put that within this eval command. So evaluate it, and then it would load it, and then I want you to set the load equal to file name. So that's what it's doing. Now, now that the data is in file name, you can come in here and you can generate a new figure based on this integer count. So it'll be a new figure every time. I just like to do it that way. And then here's this contour thing where it's going to plot. And here I'm actually telling it the values of the contour using the square brackets. And I set the line width and then I label it. And then this is kind of a cool command. This is this print PNG file. So it's going to take each one of the files after it generates it, and it's going to do the same thing. It's going to generate a string called step with the iteration number, and then it's going to be a PNG file. So it's going to create a PNG file for each one of our plots. And so it's automatically doing a whole lot for us here. Let me uncomment this bit out so you can see what's going to happen if I don't have Cairo in here. So I'm going to call this like no Cairo. So here's where you're telling it what file it's going to be. It's going to be the digital file PNG, PNG Cairo. So that's, I'll show you what's going to happen there. So we save that. And when I execute this plot PSI file, what's wrong with this guy here? I execute the plot PSI file. You can see now it's putting each one of these files onto the screen there. It's just popping, it's going to do all 40. And it looks kind of like it's time accurate here, but keep in mind, right, this has nothing to do. This is not like a time accurate startup on flow over a step. This is just converging to the solution. And it doesn't really mean anything physically, the fact that this flow is changing. So only the steady state solution has any physical significance. So it's going to continue to do that. It's quite slow here. I think I'll stop it. So I can plot these to file just by typing plot._psi. And there it goes. Now it's showing each one of these. It's showing the 0th and the first iteration, the second iteration. You can see the flow field is changing. This flow field, as it changes, has no physical significance. This isn't the time accurate flow field, right? This is just marching towards a solution. So you can ignore this part where it marches towards the solution. Now what it's doing here is, let's go back to where we are within this. We're doing flow over simulation in Octave, in 6. It's generating these PNG files. So you can see here they are right here. And then it's also generating these no Cairo files. So the no Cairos, you can see they're all blacked out, which is why I don't like that particular look. So that's why I use the PNG no Cairo. So I think I'll go back and just comment this out so I don't get that in the future. Okay, so we've got our files here, up to 30, and the next thing I'd like to do is just show you some labeling and such. It's almost done here, 36. So it's nice sometimes to put a little bit of X and Y axis labels on your plot so that they look a little nicer. And so you can do that using this X label. You can see there's an X there. You can also put a title on there. So we'll put a title up there. Now, it'd be cool if that actually were the Greek letter. And the way that you do that in Matlab is you put a backslash in there like this, and that alerts Matlab that, hey, what you're going to write next is a Greek letter, and so use that size. So that's how you do that. It'd also be kind of cool to put the iteration number on there. So you could say something like Matlab iteration say at num2 string of II, and when I run this script, or if I put this in the script, it would do that. Now if I hit return here, yeah, see, it just put it up there. It took that literally. So what I need to do is let it know that this is within a build. So I got to get this out of there. This. Okay, doesn't like that. So what we do is we put this within a cat string. So that means concatenate this string into one string. And it did that for us. Let's put a space in there so it looks a little nicer. So you can see, and then if II changes as the iteration changes, this label will change automatically for us. So that's kind of a nice thing to do. And then you saw where it plots out the how I got it to plot. So that's pretty cool. Now the last thing I wanted to show you was if I get out of this and you look in your directory, you see you got all these PNGs. Let me get rid of those Cairo PNGs. So I'll do remove star dot, let's say step no Cairo, and then I'm going to put the star in there. What that star means is if your file name matches up to here, and then the star is a variable, and then anything else, then you're part of this set and it will remove you. Now that's a really powerful command, and you want to be careful because you can accidentally delete everything with that star if you don't restrict it enough. So you can see I got rid of all of those Cairo PNGs. If I go in here, you can kind of play a movie, which is what I generated for you in the previous lecture, and I just stepped through this and it looks like a movie. But the way to do that on the command line is you could use this ffmpeg command, and it looks like that. Now I'm going to say I want the frame rate, R, is going to be 1 frame per second. And then the file names, the inputs that I want you to use are the step files with the 6-digit and they end in PNG. And I'd like you to make for me an output AVI file. Let's call it output.avi file. So there it goes, and it made this new file for me. There it is, output AVI, and you can see it up here too. There it is. And I can open this file, open output AVI, and it's going to open it in whatever this is, QuickTime, I guess, and I can play this file. So that's pretty cool, right? That's a command line command that I use, and it's called ffmpeg. And you can go here and you can download ffmpeg. And it's a crazy powerful image manipulation. It's cross-platform, and really a lot of codes that you buy, you know, that you would pay money for, like if you go to just kind of Google putting together an images. Really what that is somebody just wrote a GUI and wrapped ffmpeg around that GUI. There's another one called Image Magic that I really like, and I'll show you a little bit of that next time. That's it right there, Image Magic. And this is another one that you can use to create and change images. This has been around a long time. This is basically the underlying driver for a lot of commercial codes. This is what it actually uses to do its image manipulation. Okay, so did I cover everything that I was going to cover here today? Let's see. The contour plot, the sea label, yeah. All right, so I think I'll wrap it up, and we'll meet again next time, and we'll go over the next step, which is I would like to increase the resolution of this and compare solutions. All right, see you again next time. Bye.